Now in this question we're going to factor each of the following trinomials, and then we're going to expand and simplify to check our answer. Well, if you look at this polynomial, it has three terms, and none of the terms have a factor in common, so we can't common factor them. In other words, the 24 term doesn't have an x, and these two terms each do, so we can't factor out an x. And the leading coefficient is a 1, and so we can't factor anything from 1, 10, and 24. So what we're left with is trinomial factoring. This trinomial is ripe for trinomial factoring because the degree of the variable goes from 2, in other words the exponent, to 1 to 0. So what we're going to use is the sum and product method. We're going to look for two numbers, which add to 10, the sum, and multiply to 24, the product. Well, thinking a little bit about it, we realize that those two numbers are positive 4 and positive 6. So we can write that this equals x plus 4 times x plus 6. Now, the question also tells us to expand and simplify to see that we got the right answer. So by expanding, we get x squared plus 6x plus 4x plus 24. And then when we collect like terms, we see that we get x squared plus 10x plus 24. In other words, we got the right answer. Move to the next question, and here we've complicated it a little bit. We're looking for two numbers that multiply to negative 36 and add to positive 5. Well, for two numbers to multiply to a negative number, one of them is going to be negative and one's going to be positive. So what two numbers multiply to 36 and have a difference of 5? And those two numbers are 9 and 4. So we then have to decide which one of those two numbers, 9 or 4, gets the negative sign. Well, negative 9 plus positive 4 does not equal positive 5, but positive 9 plus negative 4 does. So we write x plus 9 times x minus 4. Now a question that I sometimes get from students is, does it matter what order I put them in? Can I make the first binomial x minus 4 and the second one x plus 9? The answer is yes, you can. So x times x is x squared. X times negative 4 is minus 4x. Positive 9 times x is plus 9x. Positive 9 times negative 4, minus 36. When we collect up our like terms, we get x squared plus 5x minus 36. And check that out, we got the right answer. We move to the next question. X squared minus 10x minus 24. Well, like the last question up here, we know that we have to have a positive and a negative number. What two numbers multiply to 24? Well, we could certainly try 6 and 4, but if we try 6 and 4, we see that if we make 6 positive and 4 negative, we won't get a sum of negative 10, and if we make 6 negative and 4 positive, we won't get a sum of negative 10. So we have to try two numbers other than 6 and 4. So we can try 3 and 8, but those don't work. So we're getting to see here that there's a real trial and error aspect to this. Or we could try the numbers 12 and 2. 12 times 2 is 24, and if we let the 12 be negative, then negative 12 times positive 2 is negative 24. Negative 12 plus positive 2 is negative 10. So we can write that this is equal to x minus 12 times x plus 2. Well, we now expand. X times x is x squared. X plus 2, or x times 2 is plus 2x. Negative 12 times x is minus 12x. Negative 12 times positive 2 is negative 24. And when we collect our like terms, we get x squared minus 10x minus 24. Look at that, we got the right answer. And last but not least, x squared minus 11x plus 28. Well, we see a negative term here and a positive term here, and that might seem puzzling until you remember that two negative numbers can also multiply to a positive number. So what two numbers add to negative 11 but multiply to positive 28? Well, we try negative 7 and negative 4. because negative 7 times negative 4 is positive 28, and negative 7 plus negative 4 is negative 11. We get x minus 7, x minus 4. Again, the order of the binomials is not important. X times x is x squared. X times minus 4 is minus 4x. Minus 7 times x is minus 7x. Minus 7 times negative 4, that's positive 28. And we get x squared minus 11x plus 28.